Hey, let's have a look here. Suppose that a particle moves along a straight line with that velocity. Find the displacement at time t. Okay, so you've got to remember that velocity is ds dt. So s, which equals the integration of ds, which equals the integration of ds dt, that's equal to the integration of v dt. So that would equal the integration from 0 to 2, 0 to 2, r minus 2t dt, which would be rt minus t squared, 0 to 2, which is going to be 8 minus 4. So that is 4 meters displacement. Let's check the answers actually, since we can check the answers as we go. 2, 2, what's it now? 2, 2, 2, 2, 3, 4. Okay. Suppose that a particle moves in a straight line with velocity. Find the displacement at time t and the total distance traveled up to t is 6. Oh, okay. So we'll just integrate from 0 to 6, 0 to t, and let's use a dummy variable so not to confuse things. X squared minus 3x minus 18 dx. So that would be x cubed over 3 minus 3x squared over 2 minus 18x, 0 to t. That would be t cubed over 3 minus 3 over 2 t squared minus 18t. So s at 6 would equal, calculator, 6 cubed divided by 3 minus 3 over 2, 6 squared minus 18 times, 6 cubed divided by 3 minus 1.5 times 6 squared. That's minus 90 meters. Let's just double check that. Yeah, minus 90. Okay. Suppose that a particle moves along a straight line with velocity defined by that. Find the displacement. Okay, same again. Now, t is between 0 and 6. That's very interesting. So that would be integration from 0 to t, 2t minus 6 dt, which would equal 0 to t minus 2t plus 6 dt to ensure that it's positive. That would be minus t squared plus 6t, 0 to t. Oh, I should have used a different letter. Doesn't matter. Minus t squared plus 6t. So s at 6 would be 0 meters. Let's see. Oh, it's okay. I, ah, 0 to 6. It only is positive from 3. It's negative up to 3. Ah, ah. Oh, that's going to make it really tricky to calculate it at time t, because that's going to depend on whether or not it's more than or less than 3. So if it's less than 3, this would be like a negative. So it'd be minus 2t minus plus 6 dt. So that would be minus t squared plus 6t 0 to t. So that's minus t squared plus 6t. But if it's more than, what you would have to do is split it. So it would be 0 to 3 plus 3 to t is the idea. So that would be 18 minus 9, which is 9, plus minus t squared plus 6t minus 3. Oh, sorry. No, that's actually, it's t minus 3. Isn't it? Or, yeah, and then we put in this number. It's 18, so it's 9. But what's different here is that this would be the integration from 3 to t, and it would be positive. So that would be 9 plus t squared minus 6t, 3 and t, 9 minus 18 is minus 9. So that would be 18. So that would be t squared minus 6t plus 18. So the formula then would be st minus t squared plus 6t if t is between 0 and 3, and then t squared minus 6t plus 18, more than that. So then at 6 would be this second formula, which would be 18 meters. Yeah, that's right. Okay. Okay. Two two five. Okay. Now 226. Suppose our particle moves along a straight line with acceleration defined by that between 0 and 6. Find the velocity and displacement at time t and the total distance traveled up to t6. And velocity at 0 is 3 and distance at 0 is 3. Okay, so find the velocity. So the velocity would be the integration from the initial velocity. Find the velocity, okay, from 0 to t. T minus 3. That would be t squared over 2 minus 3t 0 to t. So That's t squared minus 2 minus 3t. Um, hmm. But, yeah, dv dt. V0 is supposed to be 3 though. So I really need a plus 3 in here. I want to get the syntax right here. So this would be dv, and it'd be 3 to v, but we could change this to dt, which is the acceleration. Hmm. Hmm. I, I'm just a bit confused how the integration works. I know how to do it, but how to do an integration with limits. Um, uh, you could say the velocity is the integration of t minus 3 dt, and that would be t squared over 2 minus 3t. But when t is 0, we need a 3, so there's a constant of integration here. But 0 to t. Hmm. 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 What limits could I put here to make that? Let me check something here. Hmm. Let's continue. Hmm. Displacement would be the integration of t squared over 2 minus 3t plus 3 dt. That would be t cubed over 6 minus 3t squared over 2 plus 3t. And displacement. Are they using d for displacement or d for distance? Well, okay. I think distance will equal display. Better graph this to see what's happening. Find the velocity and displacement at time t. and the total distance traveled up to T6. So the total distance traveled would be the integration from 0 to 6 absolute of t squared over 2 minus 3t plus 3 dt. So, oh dear. It crosses the x-axis twice. Oh, they've made this question so difficult. Okay, I'm going to clear it off and do it fresh. I just want to be clear what's going on here. So the acceleration, so that's dv dt, that's equal to t minus 3. So like I said earlier, we want the velocity. So the velocity equals the integration of dv, which equals the integration of dv dt dt, which equals the integration of acceleration, which equals the integration of t minus 3 dt, which equals t squared over 2 minus 3t. So the problem is there's a constant of integration here, which has to be 3. Now, to get the displacement, that would be the integration of the s dt dt, which is the integration of v dt, which is the integration of the answer I just got. So that would be t cubed over 6 minus 3 over 2 t squared plus 3t, and we'll assume it starts at the origin. So there's the velocity, and there's the displacement then. Okay. And then the distance will be the integration of the speed, the absolute. So that would be the integration of a half t squared minus 3t plus 3 dt. And absolute. And now the problem is they want it for 6. So we need to get the roots here. Oh, why did they do this? Why did they do this? The roots are 3 plus root 3. 3 minus root 3, which unfortunately, both are in the integral. So that would be the integral from 0 to 3 minus root 3. And it's positive, so I can just use v. And then it goes negative 3 minus root 3 to 3 plus root 3. And then we have to flip the sign. And then it goes back to the positive region again. 3 plus root 3 to 6. Ooh. So that would be a sixth t cubed minus 3 over 2t squared plus 3t, 0 to 3 minus root 3 minus integration of the same thing, 3 minus root 3, the 3 plus root 3, plus, and then the same thing again, 3 plus root 3, 6. Oh, okay, let's type all that in on the calculator. I might want to check the answer in some graphing software because it's an even number. It's not going to have it. And okay. Integrate this, and the constant is 3. So that's the velocity, the acceleration, and then we'll have to integrate this again. Okay, and that's the displacement. Okay, so let's just check now. Oh, and then the distance. Well, that would be integration, absolute velocity integration and then that is the distance. Now, oh sorry, my calculator gave me an answer here of 6.93 meters. So let's see. Root 6. Root 3. So I must have typed in something wrong on my calculator. Or I typed in something wrong here. Where's velocity now? Let's just check actually that this is 0. No, it's not. Ah, so the constant of integration, that's the problem here. Did I not set it as 0? Okay. Hmm. That's weird now. Something's gone, the software's not correctly, uh, something's not quite working out here. Yeah, it's not quite working out right for the formula. So let's just integrate it directly and see what happens. Okay, that's the answer I got here. I'm going to grab the velocity. Yeah, it goes negative here. So let me um, grab this. So it's this area, and this area. Yeah. I don't know. I wish I had the answer to check for this one, but I don't. Well, this video is getting a bit long, so we'll leave it there. We'll leave it there for today.